Okay, V1T is given as 4 cos. So, oh no, I forgot to so for the attendance, okay, I will after this maybe I share with the question first, then you maybe can try to solve it first. Okay, and V2 is actually negative 10 cos 377t plus 20 degrees. Okay, so the question is which one is leading and how many degrees? Okay, how many is different lah. Okay, so maybe you can try first before I share with you the attendance link. Okay, so let's discuss this one. So as you can see, this one V1 is already in the cos function. So you need what you need to do is actually to convert first into a phasor. Okay, so this one is 4 with an angle of 10 degrees. Okay, but for the second function here, you cannot directly convert into a phasor because you have negative here. Okay, so what you need to do sometimes is actually for me it depends on you. Okay, but for me what I can do or to simplify the difficulty of memorizing the cos function, okay, the transformation from cos to sine and so on. So I use the what you call the phase, right? But it's actually we have another alternative, okay, where you know that this one V2T is actually negative 10. You can actually extract as a negative 1 multiply with positive 10 cos 377t plus 20, right? So from here, you can actually, from here, you can actually transform into a phasor. So in our previous class, which is yesterday, so negative 1, if you convert into a phasor, it become 1 with an angle of negative 180 degrees. Is it correct? Okay. And this one is 10 with an angle of 20 degrees. So this one is actually, you can have the values of the, after the phasor is equal to negative 180 plus 20, so negative 160 degrees. Okay. So which one is leading? So from here is quite difficult. Okay. You need to imagine, or for simplicity.
السلام عليكم دكتور.
Sorry, Waalaikumsalam, yeah.
دكتور, for this recording, can you put it in the YouTube?
Yes, of course.
Okay. Okay, thank you, Doctor.
Okay. So right now we have already obtained, this one is V1, capital V, because it is in phase domain, and this one is V2. Okay. So right now, the first question is which one is leading? So for me, it's better to draw the phasor plane. This one is a phasor plane. Okay. So we draw the V1. with, okay, 4 with an angle of 10. So positive 10, this is positive 10. So meaning that it is here from 0. This one is a 0 degrees. Okay. Okay, positive 10 degrees. And then V2 is 10, negative 160 degrees. So this one is negative 90 degrees. So this one is positive 90 degrees, positive or negative 90 degrees. Okay, or negative 270 degrees. So this one is actually negative, meaning that it starts from 0 and then it swing here. So this one is negative 160 degrees. So this is your V2. So right now, which one is leading? Which one is leading? Can you give me the answer? Which one is leading?
V1.
Okay, V1. Some of you say V1 is leading. Any answer that V2 is leading? No. Okay, so your answer is correct, where V1 is leading V2. Why I said V1 is leading V2? Because if you can see, if you put your eyes here and the phaser is actually rotating, right? It's actually it's we rotate. Okay, so actually, if you put your eyes here, it depends actually. You can say that V2, I will see V2 first, and after that V1, right? Is it correct? If I put my eyes here, I can say that I see V2 will come first, and then after that it's V1. Is it correct? Logic tak?
Ya, Doctor.
It's logic, because if I put here, I cannot see which one is leading, because I can say that I will see V2 first, and then after that V1. But why I say that V1 is leading? This is correct answer actually. If you say that V2 is leading, this one is not correct. Why? Why I say like that? Because you need to see. This one is actually come from your friend. He asked me personally, and from that, thank you for highlighting this problem. Okay. So why I said that V1 is leading V2? Okay. You see that which one? If I say that V2 is leading V1, the face here is very big, right? It's bigger than this face different. This face different. Which one is very big? The green or the red one? Is bigger. The face different is this one. And the other one is this one. Which one is bigger? Face different. Should be the green one. Is the bigger, right? Yeah. Okay. So usually, if I say that V2 is leading V1, meaning that I will see this one come first. And then I will use this face different. Okay. And then after that, I will see V1. Right? But it is wrong, because usually the face different will select the face that has the smallest phase difference between these two voltage. So that's why if I use this V2 is leading V1 by how many degrees this one? This one 160, 170, 170 berapa? Okay, 140 lah. 140 Betul ke?
One
Here,
190.
190. Okay. So the phase difference here is 190. Okay. Okay. So what I want to highlight is actually to see whether which one is leading. You should look at the smallest phase difference. So if I say like V2 is leading V1 by 1, but is V1, so this is not correct. Okay, it is not correct. It should be use the smaller phase difference. So the smaller phase difference is this one. So I see from, if I use this phase difference, so I will say that I will see V1 come first, and then after that V2. So that's why V1 is leading V2. So this is correct answer. Okay. This is usually student confused when the phase difference is very big. So the phase difference is this one, this amount. Okay. 160 degrees plus 10 degrees, which is 170 degrees. So the phase difference is 170 degrees. So I can say that V1 is leading V2 by 170 degrees. Okay. There is no problem if the phase difference is very small. For example, if you have this one is your V1, okay, and this one is your V2, okay. So there's no, I think no problem, right? Because you will, they automatically will see that you will say that V1 is leading, right? Is leading V2, right? So usually student confuse when the phase difference is very, very large. So we don't know which one is leading and which one is actually lagging. Okay. So, okay. So, and then what else? I think I need to clarify or more on the phases lah. Okay. For example, you also have V1 is equal to 5 with an angle of 20 degrees. So if I write my phase plane here, phase diagram. So if I plot this one, I will have my V1 is like this. Okay, with a value of 5, and then the angle is positive 20 degrees. Okay. Another one is actually this one, the phase difference here is 360. So I can say also negative 340 degrees. I can also, actually this one is similar if I write like this, 5 with an angle of negative 340 degrees. It's actually same, okay? But it is using the negative angle here. But it's actually will represent the same location, the same phasor location, which is V1 here. Okay? And then what else? Anything that you want to ask me? Okay, let's say something much different. For example, 30 degrees. Negative 5, 30 degrees. So in a phasor, if you have a negative, okay, if this one is positive, yes, you will have this one, 5 with an angle of positive 30 degrees, right? Positive 30 degrees. But what if you have V2 here, V1 is equals to negative 5, 30 degrees. What is the phase diagram that represent this one? Negative 5, 30 degrees. So the angle is still positive 30 degrees. Okay, but the arrow is going into the origin. Okay, it's not going out, but it's actually going into. So this one negative. Hold on, I have someone call me. Okay, sorry. Okay, so if you have this one, negative 5, 30 degrees. So it is actually, I can, this one negative, okay? So meaning that the arrow is going into the origin. Or I can also, this one, because I want to make it this arrow going out. So I can draw like this also. So after, if I draw like this, so this one is become positive 5. So my angle is right now is, because we know this total is 180 degrees. So meaning that this one is negative 150 degrees. So I can say that I can write down this one is equals to positive 5. Okay. If you are not very sure or confident, let's say that this one, negative 1, 5, 30 degrees, right? So, and then we know that this one is equals to negative, is equal to positive 1, negative 80 degrees, 5, 30 degrees. So I will have this one positive 5, negative, right? What do you mean accept? Yes. Yes, acceptable. One, why? Negative. You mean 5 with an angle of 30? Is it?
Doctor, I think Hui's meaning is for this question we can the answer can be 210 degree because
Oh,
30
okay. Yes.
degree
Yes, yes, correct. Yeah, correct. Yes. You can also from here to here. So this one is uh 210, right? Because 180 plus 30. Yes, correct. Yes, you have also, you can write also like this, positive 210. Correct. So this one okay, this one okay, this one okay. Okay, so from here you can actually represent, there are two ways, okay, from negative angle or positive angle. Yes, both are accepted. Okay. So, what else that you want me to highlight? Uh, this one, the subject as mentioned previously, you need to have exercise lah, exercise. Rather than that, I think should be no problem. But this one, yeah, this one is actually a trigonometry basic theory, but I think it's good also if I can refresh back. Okay, what is negative 5 and so on. Okay. So please be noted that your second test will be on 19th of January. I think today is Monday. Okay, Monday. Tomorrow is Taipusam. Okay. Okay, actually, for your information, I have not taking my booster today because uh, so I postpone it actually because there are a lot of some uncertainties on the boosting effect on our body. Okay. So I have postponed it. So that's why we can have the class at 12. Okay. Okay. Test to pass your sample. Yes, I will give you after this. I need to tengok balik. Okay, need to check in my folder whether it is. I think there are samples, but not much. Okay, I will share with you in the WhatsApp group. Okay, so if there is no other question from you, then I think we can
Doctor,
dismiss. Yeah.
sorry, doctor. I have one question that personally message you inside the WhatsApp.
Okay. Which one? 10.11 or
Yeah, yeah.
10.11?
Ah,
10.11. 10.11. Okay. Okay, I hope you can see this one. And I think we can share. Okay, let me share. So that everybody can have that copy. Using nodal analysis, find I/O in the circuit. Okay. So right now, the source given are in one is actually sine, and one is cos. So I need to convert the sine into cos, or vice versa. Okay, it's up to you, but for the what you call standard, so we convert the sine into cos. Okay. Nodal analysis. This one it will be time consuming because this one is time consuming because you have this symbol ML, meaning that MATLAB. This one is actually requires some software, which is what we call MATLAB. Okay, so meaning that it is time consuming. Okay, and then sine into cos. Sine omega t is equals to what? Cos omega t plus 90 degrees, is it? Betul ke? Sine, this one is sine, cos, okay? Okay, so sine omega t is equal to cos 90 degrees. So if you have this one, so this one will become 90 plus 30 degrees. So this one is 120 degrees. Okay, and then you have resistor, and then this one all you need to convert into reactance. Okay, so this x1 xc here is negative j 1/2 multiplied with
Sorry, doctor.
Yeah.
It's negative 90 minus 90 degree.
Oh, yeah, sorry. Yeah, negative. So this one will become 60. So this one will become 0.5 multiplied with 2, and then inverse should be 1. So this one is negative 1, negative J1. And then, oh, this one very simple. Then this one is already 1 with an angle of 0, okay, because there is no phase. And then this one is J2 ohm, omega multiplied with the Henry. Okay, and then this one will have another reactance. So negative 0.25 multiplied with the omega, which is 2, and then inverse. So this one become negative J2, and this one will become J 4. Okay. So for the nodal analysis, this one, the question is calculate the IO. So nodal, so meaning that you need to identify the node first. So you have V1, V2, and this one is V3. This one is 0 voltage. And then the current direction. So the current direction I pick.
Doctor,
Yeah.
for the one voltage source is 30 degree minus 90 degree, right?
Yes. Oh, okay. So this one should be, thank you. So 8, negative 60 degrees. Okay, sorry. Negative 60 degrees. Okay, so identify the current direction first. So this one like this, and maybe this one. So IO is this one. Okay. But if you can see here, only there are two unknown voltage, which is V2 and V3. V1 is already known. Okay, V1 is, we know that this one is 0, right? 0 voltage. So V1 minus 0 is equals to 8 negative 60. So that's why we have V1 is 8 negative 60 degrees. Okay, directly you can put like that. So this is the first equation. Next is KCL at V2. Okay, KCL at V2. So you have one current input and two current output. So V1 minus V2 over 2 is equals to V2 minus 0 over negative J1. Okay, and then plus V2 minus V3 over J2. Okay, so from here, you can simplify this one. So this one will become 2V2 negative, so J negative 90 degrees plus V2 minus V3, J2, wow. So it will be very, very long here. Ataupun tak perlu. Negative J1. So this one will become J4V2 plus, sorry, negative J V2 plus JV3. So this one negative J and J, so it will be positive 2, okay? Because negative J multiply with J, so it should be negative positive 1, okay? Because negative multiply with negative 1, multiply with negative 1, so negative 1, so berapa Negative 1 multiply with negative 1, 1 lah. So negative, sorry. So this one is negative 1. Okay. So this one should be negative 2. Betul ke? Tak. Positive. Okay. Because negative J multiply with J, which is negative 1. Okay. Multiply with negative 1 square. So is 1 will become negative 1, right? Okay. So if you have like this, so this can positive 2 lah. Okay. And then it's time consuming here. So this one will become J3V2 plus JV3, and this one is equals to 2V1 minus 2V2. Oh, time consuming. I hope you are still with me. I think I will try to, because I cannot concentrate right now, because it has a long calculation step here. Okay, so and I don't want to do mistake here. Can I skip this one, and then I will share with you the solution first. Okay, after this. Okay, sorry for that, because this one this requires some time. It requires a very lengthy time here, because the symbol here meaning that it is a very complicated steps.
So means that the final
What
exam
is
will come out like this hard question, no?
No. Usually, during the process of preparation of the questions, so the lecturer will usually will do the answer first. Will actually assume the time, whether the time consumption, the time for the student to answer, is it enough or not. Okay, so we have, don't worry, we have final exam, we have what we call a panels of a final examination assessor that they will comment whether this question is suitable or whether the student can answer it within the time given or not. I think this is not very hard. What is the problem when you dealing with this question? What is the problem arise? Is it because of time consuming or
Because I a little bit too complicated. I don't know how to calculate the inside the equation.
Yeah, because when you dealing with the complex numbers, okay, when you dealing with complex numbers, for example like this, you will have a what, sometimes you will miss j, or sometimes you miss negative j, sometimes maybe you miss on multiplication negative j multiply with j. So the problem will be on that lah. But usually for our examination, we will not have this kind of questions. This is very tough actually. I can see that from this circuit, when this symbol come, so I can see that this is a very complicated solution. Okay. It's time consuming here, and because I don't want to other students to maybe they have not very interest. Okay, so I think I can skip this one, and I will try to solve it, and then I will give the steps. Okay, for you. Okay, sorry for that. So is there any a simple questions, not very what you call complicated like this one because the purpose of this class is just to maybe to clarify something, clarify a concept, the idea, the concept, okay, the fundamental concept of the circuit and so on. Okay, this one pun nampak saya takut ada tertinggal kat sini. Okay. Selalunya when I do the solution, I will memang kena concentrate, because when you dealing with the complex number kat sini, memang you will do some mistake here. Okay. Okay, if there is no question, but thank you very much for these questions. Okay, so for those who may interested to proceed, you can proceed, try to proceed this one. So the answer is already there, right? 10.11 ni, so the odd numbers, the answer is there. So you memang tak dapat buat lah You sangkut ataupun memang tak dapat jawapan? Memang tak dapat?
Sangkut.
You cannot get the answer? Because you stuck. Okay. I think no problem here, because I think this question is there is no problem, because even though you have 3 variables here, but this one is already known. V1 is already known. So you are dealing with 2 simultaneous equation, which is V2 and V3. But the complexity is become when, because you have a lot of imaginary numbers here. Real numbers, imaginary numbers, addition and subtraction of the complex numbers, so it will become very, very hectic. But for your final exam, no problem, because we will have that this called the simplest lah. Okay. Okay, thank you very much. So we meet again on your final exam. Your final exam pula. Your second test. Second test is actually in the 9 p.m. right? 9 p.m. if not mistaken, 9 p.m. I will confirm back later. Okay. So thank you very much. I think that's all from me. Can we have the photo session?